Okay, guys, so let's start. Let me open. Let's start with a couple of exercises and see how good we have got these ideas. Okay, so imagine, guys, while we wait for your colleagues to join, imagine let's do a discount, okay? And we are going to add something more here. So imagine, guys, that you have a IOU, okay? Someone owes you money. And let's assume that someone owes you money for $100,000, okay? And the maturity is going to be in, let's say, 100 days. The settlement of the agreement, oopsie, it's terrible, has been done on, let's say, April 28, 2001. Okay, so we are here today at 06/10/2001, so it's 10 of June 2001. And the interbank rate for a discount is equal to 2.5% per month. Got it? So first of all, I want you to find the discount. So tell me, what is the liquidity you can receive here if you're going to do the discount of this document? I want you to find the bank's discount. So this is my liquidity. How much money you're going to receive? My bank's discount. And also, there is a new formula, guys, for bank's discount. And I want you to do this because it's important to use these type of things. Bank's discount also, guys, is equal to, let's say, the principal, so this number here, times the interest in advance. Okay, so what I want you to do, so this is A, B, and C, and I want you to compare that this formula here provides, so C provides the same answer as B, right? Okay, guys, let's do this in 3 minutes. This is in advance, remember.
Prof, that was actually one of my questions I wanted to ask you today. So when you did this before, you used IV. So does the IV stand for
this one?
Arrears.
This one here. This one here is the interest rate that you pay at the end of the term.
Arrears.
Yes. Okay. So this is the regular one when you pay the interest at the end.
Okay.
So it's at the end. So this one here is like yes. Yes.
Because I thought advance, maybe the V from the advance, maybe was advance, but it's the other way around.
Right. So this one here is you pay in before the start.
Advance. Okay.
Okay. Yes. This is at the end of the period.
Thanks.
This is the regular one. So normally we use this one here, but we can compute. So you need to transform the this one here or this one here.
Yeah. Okay.
Go ahead, guys. First, compute the liquidity bank's discount as regularly, and then we go for this one.
Hi, Prof.
Yes.
Ron is asking if you can please let him into.
Oh, yeah, yeah, of course. Yeah, I forgot to. Yes, I will do this right now. Thank you.
Prof, just another question.
Yes, go ahead.
So in finance, I know we use 30 days, but here we can know exactly that there was 31 days in May.
Yes.
Do we use 30 or 31?
Yes. No. For this one here, you use the exact number of days in the month. For a transformation, then remember, this one here, when we say month, normally we say 30 days, okay? But for this one here, it's exact number of days. If you have 31 days, you use 31 days, okay?
Okay, cool.
Okay, 2 more minutes, guys, and then we continue. Ready, guys? Someone can give me a number here for the question A. Someone?
I got $95,416.75.
Okay, I have one answer. Someone can confirm. Guys, someone can confirm.
I got 95,495.33.
And 33 cents.
Yep.
Yep. I have another question, another answer. Someone?
I have $94,790.53.
Okay, we have 3 answers already, guys. Okay, let's do this. Let's do this. So how many days do I have? This is April right now. Yeah, see, April. April had 30 days. So I have in April I have 2 days.
And then 31 in May,
May 31.
and then 10 days in June.
10.
So
Okay,
43.
perfect. So we have here 43 days. So if we have 43 days, so from here to here, because it's 100 days, we should have 57 days, right?
Yes.
Okay, perfect. Then my liquidity is a simple discount. So you need to have the future value is indeed $100,000, right, guys? So the value of this $100,000 is not here. It was signed here, it was settled here, but it will be paid in here. So here is where we have the $100,000. So it's discounting. So you move this to the present, to this day. So it's going to be $100,000. And then you have the rate. The rate is 0.025 per month. So this one here is going to be 30. How many days will we put here?
57.
57. Completely right. And then we get the answer. Someone can verify, please. So what do you get here? Can you do this, please? 2 or 3 guys do this and tell me what number do you get? Guys?
Yeah, my answer hasn't changed. It's still the same as 95,416.75.
Yeah, I need someone to confirm, guys.
Yeah, I got the same thing.
Yeah.
Okay, got it. So perfect. So this is the number. So I can delete this one here. So when you replicate this one, you're sure that you're getting the correct answer. Got it? So now if we want to use the bank discount, the traditional way of computing bank discount, guys, it's very simple. It's simply how much money is the face value of this one here, minus what you pay, sorry, minus what you get. So basically the bank's discount is basically what the bank keeps with them, right? So what do we get here? For no. What is this number? This minus this. Someone?
I got $4,583.25.
25 cents. Got it? Perfect. So everyone is agreeing with that. Now, I do this just to remember, guys, that this is also an important type of question. So normally you need to know how to transform versus in advance versus a normal IB. So remember, guys, that if we have the traditional model is if I have P here, okay, if I have an interest rate charged in advance, and I will pay here P, okay? So this is a traditional model in advance. So this one here, sorry, it's not IA, it's times 6. So my IB, so the traditional interest rate, guys, is going to be what? I'm sorry, before doing this, you never work with cash flows that are up and down. So you need to net the cash flows. Okay, remember that, you need to net. So this one here is going to be P 1 minus IA, do you agree? And here we have P. Then I can compute now my regular IB. This is the interest rate that I always pay at the end. So this is regular one. So it's computed P minus P1 minus IA over P1 minus IA. So if you simplify this, the P goes here, 1 goes here. So IB, guys, equals IA 1 minus IA. Okay, so this is the formula for interest at the end. Make sense? Now, from here, remember what we need here is not IB, it's IA. So if I have this formula, I simply derive this formula. Very simple algebra, guys, is going to tell you that this one here equals 1 plus IB. So this is going to be the mathematical formula. Okay, so the trick here is, first of all, to find, I need to find first, what is the IB for the period? Okay, so what I need to find is what is my IB for how many days? For 57 days. Okay, because that's what I need. How do I find my IB for 57 days, guys? Well, we have it already, right? It's going to be 1.025 to the power 57 over 30 minus 1. So this is my IB for 57 days, correct, guys? So let me see, 1.025 to the power 57 divided by 30 minus 1. So I have here, this number here, guys, is going to be 0.048, etc., 0.8. Got it? So once you have the IB corresponding to the period that we're looking for this period, then very simple, IA of 57 days is going to be equal to, using this formula, IB 0.048 divided by 1 plus 0.048. So this is equal to, divided by 1.048, more or less. So it's going to be equal to 0.4583. Got it? And then finally, once you have your IA, you simply compute this formula. So bank's discount is going to be simply $100,000 that multiplies 0.4583, and then we get $4,583,000. That is basically, yeah, you're on rounding errors. It's basically this number here.
Prof, isn't it 0.04583?
Where? Oh,
Yeah,
here.
that-
Yes,
yeah,
yes,
0.0.
completely right. Yeah, so I'm hungry, so I ate 2 zeros here. That's why. So this is going to be 0.045. Completely right. Oh, and also here. And 0.4583. Here we go. Got it? Makes sense to you?
Yeah, and I think that last answer, if I'm correct, the
Perfect.
bank's discount is 4580.
Right. Oh, 4580.
80.15 if you want.
Yeah, should be closer to this number. Yeah, but you know, that's okay. We just use the calculator. Okay, guys, copy this one here and let's do one additional question, then we move into the class and then we continue the class. Okay. So now let's do something, and you tell me. Okay, you tell me. At this point, you should be able to tell me. You know, I created this example a long time ago, and it was kind of fun. So take a look to the following example, guys. Sorry. So let's assume the following example. Okay, so you have the following cash flow. So you get a loan for $200. You're going to make 2 periodic payments. Okay, let's assume that this is a 1 month, 1 year. So you pay 110, and then you pay 110. Got it? So this is your cash flow. Now, what I will tell you, I ask you, okay, what is the interest rate of the period? Okay, well, very simple. What I will do is I will do 110 that I pay here plus 110 that I pay in, so let's call this years, okay? So this is 1 and 2. So 110 plus 110 minus the 200 that I've paid over the 200. So if I do this, this is 20 divided by this is 10%. So this is my interest rate for 2 years. Right, so what is my annual interest rate? Well, if this is true, 5% will be my annual interest rate. Correct? Do you agree with me or not, guys?
Yes.
Yes, 100%. It's completely right. Agree, everyone? Guys? Yes.
Yes,
Yep.
Prof.
Perfect. Okay, guys. Question for you. Okay, and you have 3 minutes to do this. Show me that this reason is wrong. Financially, this is completely wrong. Tell me why. Okay, think. 3 minutes to think and try to do something. Show that that 5% annual is not correct. You can do an example, do whatever you want. Guys, do you remember when we did line 1 and line 2, and it's going to be part of the quiz this night? Remember that? So try to use that logic, okay? Use your project. So imagine, what is your project producing? Imagine the following. If your project indeed produces 5%, okay? If you have a project that produces per year 5%, are you going to be able to pay this debt? Yes or no? So you always focus on that sense. Okay, guys. So let's take a look. So imagine that your project base is able to create 5%. Okay, and you told me that it's 5% per month. So if you create 5% per month, you should be able to cover this loan. Let's think about that. So this $200 times 1.05.
So you said 5% per month if
5%.
you're, okay.
Yes. So if I multiply this times 1.05, okay, so this 200 becomes 210. Do you agree? So this is what your project produces, 10%. Sorry, 5%. Then you need to pay the 110. You are left with 100. Now this 100 produces again 105. So what you have here is 105. And you need to pay 110. So you're -5. So you cannot pay. If it's indeed 5%, guys, why is it that you are not able to cover with 5% per month? You see? So this implies, guys, that this reasoning here is wrong. And it's wrong because of what? Because uses simple interest rates, simple interest computations in a world that is compounding. How do we find, guys, the interest rate that corresponds the average interest rate per period? This is the definition of what? We have done that. What is the technical way of finding? What is the technical way of finding the interest rate, the average interest rate per period? What is the definition of that? Average interest rate, of course, compounding. Is my compounding interest rate.
Is the IRR.
Exactly.
Mm.
Exactly, guys. So basically what you do is, okay, remember the net present value equals 0, so it's going to be 200 minus 110 divided by 1 IRR, 1 plus IRR, minus 110, 1 plus internal rate of return square. How do you do this Excel, right? Can you compute IRR? Can you very quickly, guys, tell me what is the IRR?
3%.
No, should be much more. remember in Excel, what you need to do is you need to enter 200 minus 110 minus 110, and then you do internal rate of return of all this part.
Oh, 6.6, sorry.
Oh, 6.6%.
Mm.
Got it? You can take a look, guys. You need to be extremely careful with this stuff here. It's not equal. But now take a look to what happens if indeed it's 1.06. So if you multiply this by 66, so you have 220, and also 200 times 1.066. So we obtain 213. Okay, so we have here 213.2 minus 110. So I end up having 103.2, correct? And then this again to the power, not to the power, multiplied by 1.066. You obtain 110.01. You obtain 110 minus 110, you obtain 0. Makes sense to you guys? Please remember, okay? And this is a common mistake, so don't feel bad. In the last 7 or 8 years, no one was able to answer this correctly. But remember now, hopefully now you understand this part here. The correct way of finding the average interest rate per period is using the IRR technique. You cannot use this one here. This one here is used in the industry, guys. Well, not in the industry, in microfinance, or we're going to work today with commercial credits. That you go to a retailer store and buy a TV, for example, they use a lot this method here. But I will show you that indeed they use this method to steal money from you. Right? They argue that it's simple because it's simple. Do you agree? 110 plus 110 minus 100 is logic. Oh, it's 10%. And you divide it by 5, then you have 5%. Looks logic, but it's wrong. Make sense? Okay, questions? 1 minute to copy, and then we can move.
Prof.
Yes.
Yes, I just want to ask with the IRR. So I got like on my Excel 7%. So I'm worried like why the answers different.
You know what? Perhaps what you have done is you need to let me open. Give me 1 second. I will open one Excel for you. One new, and let's do this together. Okay, so I'll open. Oopsie. Yeah. Oh, I need to share my screen. Sorry. Yeah. Let's do this together. So we have 200. We have minus 100. You see my Excel, right? Guys, are you?
Yes, I can see 200 minus 110 minus.
Perfect, perfect, perfect. So we do internal rate of return. We simply select all these ones here. And indeed, look 7%, but you need to give more decimals. So if you just click here, in this part here, here you go. Do you see that?
Yes.
Okay, so it's 6.6% actually. Make sense?
Yes, it makes sense. Thanks, Prof.
Excellent, my pleasure. Okay, so now guys, let's go into the world of commercial credits. Okay, let's do a couple of examples of, what you need to be aware, guys, is how you determine the real cost of capital. Okay, so and this is a perfect environment. Commercial credits. So what is a commercial credits, guys? It's basically when you buy TVs or a refrigerator or something like that, and then you go and buy your refrigerator, okay? So normally these guys use something that is called the flat method. Okay, what is the flat method, guys? It's a fancy name for simple interest rate. Okay, so for example, if you buy I don't know a super TV, a big TV, okay, a big TV. Imagine that the price is so you're buying a home theater, 5,000. You're gonna pay this in 24 months, 24 installments. And let's assume that the interest is going to be 5% flat. So they use this name, flat monthly. Okay, so what is flat? As I told you, it's simple. It's simply. And then what they're going to tell you, how do you compute the payment in this case when you use this flat method? It's very simple. It's a principle. You're going to recognize this formula. 1 plus n times I divided by n. So let me put the formula first. So it's not 5,000. It should be the price. Should be the price. 1 plus ni over n. Do you remember this one here, guys? This is the formula of the simple interest rates. Do you remember? This is the future value of simple interest rates.
Yes.
Okay, so my payment then, remember, it's not complex as the formula we use when we have the compounding interest rates. If you put to your client the formula, you know what, it's going to be present value that multiplies 1 plus I to the n times I, 1 plus I to the n minus 1. So come on, this is collapsing already. This formula is already heavy, but simpler than this one here. Got it? And you're gonna see the logic. It's very simple. They're gonna tell you the following. Okay, the loan is going to be for $5,000. My interest rate is going to be 24 times 0.05 because it's 5% per month. They agree. And then we are going to divide this simply into 24 months. So if we do this, what do we get? Calculator. So I have I get 11,000, and then I divide this by 24, and so this is going to be equal to 458.33. Got it? So that's what you're going to be paying monthly. Now, guys, now that you're thinking as a finance guy, you need to immediately think, what is my cost of capital? The real cost of capital. Indeed, I am paying 5%. How do you do that? Remember, for the cost of capital, guys, what we do is simply, let's build a cash flow. Okay, I have 5,000 here. And then I will have 24 payments, all of them the same, or 458.33. Next month, 438.58.33, and then we have 44 payments. 24 payments, sorry. 458.33. So what is your cost of capital, guys? Someone can give me this number. You need to do this in Excel, of course. What is your cost of capital? ¿Qué tal, Jesús? ¿No? ¿Ver? Okay, guys. You should be very quick now with Excel at this point. So what technique do you use for doing this stuff? This one here is exactly the same as this one here. Do you agree? The only thing is that we have more cash flows, but the technique is the same. What technique do you use? Guys?
IRR.
Yeah. Can you please do this very quickly and tell me the numbers? Tell me the IRR.
I get 7.58%.
Okay, someone to confirm? Guys, someone to confirm?
Prof, I don't get the monthly payment you have there, but I did it in Excel, like payment.
No. Remember that this payment, you use this formula. You don't use the PMT formula of Excel, huh?
Yeah, but shouldn't it also work in Excel?
If you do the formula, yes. But
Yeah, I was using the equation.
yes, the question, yes. So you're using this one here. So basically you're saying 5,001 plus 24 times 0.05 divided 24, correct? That's what you're doing?
Oh no, well, I'm using
Not
the
this one, not this one, this
Excel.
one.
No,
No,
but I'm
no,
using the
no.
Excel function.
No, the Excel
No.
function works. The Excel function, guys, is this one here. The Excel function is for payments. This is the Excel for payments. Okay, but this payment here uses the compounded interest rate.
Okay.
Okay, so the payment that uses Excel, the command Excel, is not providing you this number here.
Okay.
Okay, just be careful with that.
Okay, thanks.
Pleasure. So what I'm doing is I'm doing a trick that that retailers normally use here, even here in USA. Okay, so we need to do this quickly. So I said it's the same. So let's do my cash flow is going to be $5,000. 400. What is the number? 400. What, guys? Is negative 483. Was
No, negative $458 and 0.33.
30. Perfect. Let me do this. 1, 2, just to know where I go. 24, right? So and this number is exactly the same. So this is your cash flow, guys. Let's say it here. This is the cash flow you are going to be working. Guys, everyone is clear here that this is a cash flow? Guys,
Yes.
come on. Yes.
Yes.
Okay, so from here, once you have this cash flow, it's very simple. It's the internal rate of return. You simply block all this part here. And let's give it a couple of decimals. 7.58%. Completely right. So what is this 7.58%? So this is the real interest rate that you're paying, guys. You're not paying 5%. You're paying 7.5% monthly. Now, if you want to see, so this is monthly. If you want to see what is your annual one, okay, so it's going to be 1.0758 to the power, this is 1 year, to the power 12 divided by 1 minus 1. So you can take a look. The component is brutal, guys. 1.0758 to the power 12 minus 1. What I'm doing? Minus, sorry. 1.0758 to the power 12 minus 1 times 100. What do you get, guys? What is the interest rate that you get? 140.32%. This is what you're paying.
Okay, Prof. So the IRR transformed it into an compounded interest rate.
Oh, the IRR always gives you compounded. always.
Okay.
Got it? So remember, the rate that you really pay is the compounded. So that's why I did this example for you guys. Indeed, this rate here is the true rate. Do you agree?
Mm-hmm.
Yes. And so in my example here, my true rate is which one? Is the IRR, the compounded interest rate. So indeed, you're not paying 5% per month in this example. You're paying 7.58% per month. That's the real one. Okay. So this 5%, looks cheaper than this one here because they have used a technique that it is called flat, it is called simple. Yes, of course, it is simple to understand. This is what I was telling to you. If you see this formula and you compare this formula with this formula, of course is simple. Simple in terms of easy to understand. But this is wrong. It's not wrong. I mean, it is correct mathematically, but what they are doing, what these stores are doing are basically, telling you a number that indeed is a much lower number than what they state.
Okay, and then also, does that mean that 1 year is the
Yes.
effective interest rate?
This one?
Yes.
This one here is so here we go, if I've done this correctly. So in the flat, guys, they're gonna tell you, so you have 5 times 12 is what?
60.
Oh, 60. So basically they're gonna tell you, oh, you're gonna be paying 60% per year. How they do this? Because it's simple. They say, oh, you know what? 5% times 12, this is 60%. Completely wrong. It's not 60%. It is amongst those numbers. It's a completely different number, guys. Make sense to you? So what I'm trying to tell you guys is that be careful when you work or someone offers you a simple interest rate or what is called also flat interest rate. Be careful. What you need to do is before getting into this deal, do this cash flow. Go to Excel and take a look to your real interest rate. So this one here is the real interest rate. I will do one more example, guys, that is going to, I think, clarify all these concepts here. But the only thing that you need to be careful is that if someone offers you simple or flat, be careful. Because most likely is that this number here is going to be much lower than the real interest rate that you're going to be paying. Okay.
Just another question before you move on.
Yeah.
That I 5%, is that then, if we had to write it in the same symbols we used before, is it IS
This one,
compounded,
yes.
compounded monthly? So it's IS 1 year, really?
No. Yes.
No, the other way.
The other way around.
IS 3 months.
Yes. This is my IS. This is my simple. No. This is my simple 1 month. Okay.
1 month.
Now the compounding. Yeah, there is no compounding in here because I don't have transformation in here.
Okay.
Yes, you're right. This is the IS. In our notation is IS. It's not I. I was this one is I. It's compounded. So this one is I compounded.
Yeah, because the confusion for me is when we say if the monthly, the word is at the back, it makes me think that it's compounded monthly.
No. This one here is simple. Okay,
but you can have a simple interest rate which is compounded at a different period, isn't it?
Yes, of course.
Yes.
Of course. But this one here, there is no way compounding. So there is no, when the store tells you something like that, in theory, this should be, when there is no compounding period, this should be compounded annually. Do you remember that?
Okay, but what I'm saying is if they put the word here at the back, it's sort of, I get confused whether it was a monthly rate or compounded monthly.
No.
Do they deliberately have to say compounded some period?
Yes, no. In this case, there is no compounding period. So it's a simple. They don't need to tell you any compounding period. They simply tell you it's a simple monthly. That's all what you need to know. Okay,
and then also, does it mean the I 1 year, the 140 is the effective rate?
Oh yes, all these guys are compounding. All these guys here. So remember that this comes from internal rate of return, correct? An internal rate of return is a compounding rate. Remember that always. This is a compounding rate. So if this is compounding rate, this is compounding rate also.
But what I'm seeing here is that you're using the word effective. It's synonymous to compounding.
Yes, Exactly that.
Okay, because our schools in South Africa taught us differently. Very
Yes.
interesting though.
Yeah. That's it.
Okay.
Okay. Okay, now let's go to another trick. And this is crucial to compare projects or to compare products. So imagine, guys, that you have store one. You have two stores, store one, and then you have another store here, store two. And now imagine that you're looking for I don't know, a small radio or whatever, and then you store one offers you $400 cash. Okay. And if you pay in 1 month, you pay 440. Got it? So what is the interest rate here? It's going to be 10%. Do you agree with me, guys? So if you go to this store, they give you the radio, you pay in 1 month, you're going to pay 440 for something that is worth today $400. So the interest rate is 10%. Now, if you go to store one, so you have the exact same product, okay? Exactly the same. There is no difference. You get it at 500. But if you pay this in 1 month, you are going to pay this at 525. So what is going to be the interest rate here? 5%. Do you agree? And what is interesting, guys, and this trick happens, if you go to the store, you know, you see in the outside windows, they offer this one here. 10% interest rate for the loan, for getting the product now, and you pay in 1 month. And the other store is going to offer you 5%. Which one do you buy, guys? From which one do you buy?
The lower one, but the store two, but I feel like there's going to be some reason that's not the answer.
Yeah, I'm thinking the same thing. It's a trick question.
It is a real life question, guys. So that's why, you know what, and this is I had one friend that did this study a long time ago. Who pay more, women or men, for the same product? What do you think?
That is a dangerous question.
No, it is not dangerous. You know, actually, it's supported by statistics. It was very, very interesting. He did one. He simply hired students, and they were in stores on heavy traffic days and hours, and simply in 2 or 3 stores that were very close to each other, they have exactly same products, and they were simply taking a look to the behavior. They were, you know, they had around 3,000 people. I think it was more or less 50-50, and they controlled by age, by a bunch of things. But the main determinant was the gender. Okay, who do you think pay more for the same product, from the exact same product? And of course, the people can walk in a mall, so you can visit one store. So which ones, who do you believe pay more for the same product?
Men.
Yeah.
That's right. You know what? And I completely agree with that personally. I don't know you guys, but I get bored going visiting stores. I just go to the first one and I buy. That's it. And then I'm walking in the mall and I see another one that is cheaper and I feel really bad. I say, oh, come on. That's it. That's life. Okay. So that's why, guys, there is a concept of doing some research. Okay. Now it's easier. You go online and you can find different sources. But the thing is that the following, guys, this one here offers you 5%. But what is the tricky part here? What is the cost of the product? The basics of this 5% is 500. The basis of this 10% is 400. Got it? So indeed, guys, this 10%, this 5% is not 5%, because the price of the product is 400. So you're paying 525 for something that you can buy at 400. Now, what is this one here? What is my interest? So it's going to be 125 divided by 400. Of course, I'm exaggerating here with the numbers. No? It's not as much as here. 125. So what do you get here?
31.3.
No, 125 minus 400. Oh, perhaps yes, divided by 400. Yes, so this is the one, 31.25%. So this is the real interest rate that you're paying here, guys. Okay, what is important from here to note, guys, how do we call this price here? This price here is called, what is called market price. So what is market price? Is the lowest price of a product. Yeah, normally in a market. So when I say in a given market, implies that you can buy. If you do a little effort, you can buy, you can find this price. Okay, so it is not comparing, for example, the price of a radio in USA versus the price of a radio in the exact same radio in China. Okay, that, yeah, of course, the Chinese price is going to be perhaps half, but you cannot buy it. Okay, and if you want to buy it, you need to perhaps do shipping, handling, etc. So it's going to be more expensive at the end of the day, or it's going to take more time for you. So the lowest price in a given market implies perhaps in a mall or in a small town or perhaps in a city. That's it. Okay? So this is the market price, and this market price, guys, is the one that is going to standardize all the analysis. We need to analyze what is the real interest rate we are paying based on the market price. Got it? So that's going to be crucial. So how much I'm paying in a given store depends on what is the market price. And remember, oh, sorry, I forget, the lowest cash price. So I need to use the word cash. So this is basically, if you have cash, where do you buy the product, guys? Of course, here, right? If you have done some research, you're going to buy the product in here. Make sense to you? Guys, yes or no? If you have cash, where are you going to go? Where are you going to buy the product?
The cheapest one.
The cheapest one, of course, at the market price. Otherwise, you're crazy, right? Or you basically didn't do your research and looking for a product. Okay, so now, based on this, so let's do one example. I want the following. So you have two stores again. You have store 1, and then you have store 2. And these are the conditions. So that, remember, guys, that the product is exactly the same. Okay, so that the product is exactly the same. So for here, I have the price. It's going to be, and this one here is going to be cash. So if you have cash, they do a discount to you. You know what they tell you? Oh, this is the price that you have, tag price. But if you pay in cash, you're going to get a 10% discount. And here they told you you're going to have a 5% discount. You understand? So, and this is what happens. If you go to a store and then you negotiate, you bargain with the seller, they tell you, okay, I give you 10% discount if you pay me now cash, okay? Now, but if you don't have the money, you're done. So you need to ask for a credit, okay? And these are going to be the conditions for a credit. Down payment. Here in this, you need to do a down payment of 25%. And here you need a down payment of 30%. Okay, and let's assume that for both it's going to be 12 months. The payments are monthly. And my simple monthly, so this is what they call flat rate per month is going to be 3.5%, and it's going to be 4.5%. Got it? And then assume, guys, that you have a bank. You have the option to go to a bank. And the bank is going to tell you, okay, you know what? My interest for 1 year equals 39.54%. I have a commission paying in advance, of course, 1%, and 12 months, and that's it. So which one do you select? Of course, you're going to select the cheapest one, but tell me which one is the cheapest one. Let's say 5 minutes to analyze this one here. So remember, in your mind, okay, in your mind, remember you need to compute what is the market price, first of all, and then you compute the payments, and then you compute the cost of credit, the cost of capital. Okay. So 5 minutes to do at least one.
Professor, what's the second thing under bank again? The 1%.
Oh, 1 year. This one?
Right. Yeah.
Oh, this is commission.
Oh, commission. Okay, cool. Thank you.
So first determine the market price, guys. Once someone get the market price, please let me know. So remember, market price is the lowest cash price. Okay. So imagine that you have cash. Which is the one that you're going to select? Which store you're going to select? That's the market price.
Rosso, does it mean the market price is that it's still 2 after the discount? Because that's the lowest one.
Yes, so that is the lowest price after the discount.
Yeah,
right?
so I've got 1729.
Okay, someone can confirm that?
Yes.
Okay, perfect. So let's do this. So 1,950 times 0.9 versus 1,820 times 0.95. Do you agree? Which one is the one that gives you, what is this value here?
I got 1755 for that value.
Okay, and here?
1729.
1729. So remember, is the lowest cash price. So basically this one here is going to be your market price. And when do you use this market price, guys? You use this market price to compute the cost of capital. Okay, for the payment, no, for the payment, you use the data that comes from the market, from the stores. How do you compute the payments? Just go back to the example we did here. This one here. This is the way you compute the payment. Agree? The market price, this one here, the 2,700 or something like that you told me, 1,729 is used to compute the cost of capital. Okay, perfect. So we have the market price, so everyone should agree on that. Now let's compute the payment for these guys here. So what is going to be the payment for these ones? PMT store 1, and you need to compute what is a PMT for store 2. So you need to remember, you need to subtract from this number here the down payment. So the payment is computed with the amount of money that you are going to owe to the store, right? So it's going to be 1,950 times 0.75, and then you do the formula. So that's the principal, and then you do your formula. Okay. 2 more minutes, guys, please. Okay. So you tell me, what do you get from payment number 1?
$230.75.
On 75 cents. Someone to confirm? Guys, someone?
I have something else.
What do you get?
It was still 173.06.
170.06. Okay, so let's compute this one here. So let me delete this part here. First of all, I need to know how much money I will owe to I will have as credit. So my credit, my P is going to be simply 1,950 times 0.75, right? Because I need to do a down payment of 25%. So what's my calculator now? Give me 1 second. So this is going to be 1,950 times 0.75. So what I will get as a loan is 1,462.5. Okay. Now I can compute my payment. My payment is going to be simply 1,462.5 that multiplies 1 plus 0.035 that multiplies 12 months divided by 12. So my PMT1 is going to be, let me do this times 1 plus. I have 173.06. So I got this number. Makes sense to you guys? Do you understand? So now if I want to compute the payment to, we do the same. What is the amount of money? So what is going to be my principal is going to be 1,820 times 0.7. So this is going to be 1,820 times 0.7. So I get 1,274. So my payment 2 is going to be 1,274 that multiplies 1 plus 0.0445 that multiplies 12 divided by 12. So what do you get here?
I have 163.50.
168.
163.
Yep.
50 cents.
50 cents. You agree, guys? Good. Okay, so we have computed the payments. The next one is doing what? So basically, guys, the cash flow here is going to be, we need to build our cash flows, okay? Just to understand. Now I need to compute, so we have done, now how do we do this one here? I will leave some space for this one here. How do I do the cost of capital? For store one, so remember, here is where the market price comes. So I will have the cost is cash is 17. The cost is going to be 1729, right? And then I have a cash flow that is going to be, in this case, 173.06, 12 times. However, I need to do another payment, guys. I completely forgot about this one. I need to do a 25% down payment here. So it is 1,920 times 0.25. So I need to do a 487.5. So my net for store one is going to be minus 1729. What do I get? What's my calculator now? I have one equals, I have here, so my net, the one that I need to do in Excel, is going to be 1241.5. And then this goes 173.06, 173.06, okay, 12 periods. So this is for store one. For store two, I will do 1729. I have a cash flow, an initial cash flow, sorry, a down payment of 30%, 1,820 times 0.3, 546. And then I do my payments that are equal to 163.5. Twelve times. Then I net these cash flows in order to use Excel. I have here 183. 163.5. 163.5. And then you go into Excel and you find the cost of credit here. Okay, 2 minutes to do this.
Professor, I understand the concept of like the market price, and I just don't understand, because if you go with store one, then you don't pay the market price. So don't you have to factor that into your decision?
No. Exactly, that's what you're factoring here. When you do, remember, when you use the market price, this market price, you are doing a standardization of cost of capital. So you are standardizing everything, because I cannot compare. That's why I did this one here. So do you agree with me that this 5% is misleading? This one?
Yes.
Yeah.
It is misleading because of what? It is misleading because of this number.
Yeah.
Right?
Oh, okay.
Then if you want to compare between two stores, what you use is the market price. Okay? So what is the market price? Is basically the lowest cash price. Okay? And then the comparison is going to be potatoes con potatoes. Otherwise, you mix up a lot of things and then you can get crazy results. That's why the market price, also in valuation, guys, market price is crucial for everything. Okay, make sense?
Yeah, that makes sense. Thank you.
Perfect. And now you can compute. Please help me computing this in Excel very quickly. Two minutes more, guys, and then we solve it. Let me share my screen. Okay, guys, can you follow me, please, for a minute? Are you there with me?
Yeah.
Yes. Okay, so what I written here is all the data that I provided to you. So we have 1,900. If it's cash, 10% discount, 5%. So this is the data I already provided to you. So my market value, as you said, is 1,729. In this case, I have a down payment of 487, and in this case, 546. The payment that we have computed, 173, 163. And then in order to compute my cost of capital is this minus this. The graph that I did in the Excel file there, guys. Then if you do your internal rate of return, you get an 896 here and an 879 here. So if you want to select, if you need to select between a store 1 or a store 2, obviously you're going to select store 2, even though they are very close to each other, but store 2 is the one that has the lowest interest rate. Okay? Now, when you work with a bank, guys, what you do is the following. Hey, you know the interest rate is annual. You transform this one here, guys, goes in hand with the thing we have been doing, a compounded interest rate. Okay, it's a compounded interest rate. It's like a normal mortgage. So you compute. Take a look to how do you compute the interest rate. You see that? Is a normal way that we compute the interest rate for compounding. So this 39% annual equals to 2.81 monthly. Then you have a 1% commissions, fees, 12 months, etc. So you compute this one here. Sorry. Yes, which price you're going to pay. So this number is not doing anything. What is this one? Oh yeah, this is nothing here. So this one here is how much money you're going to ask to the bank. Well, cash value, do you agree? So the bank is going to give you money, it's going to give you the cash to go and pay to the bank, to the store. So it's going to give you 1,729. So basically you're going to buy from store number 1, and then store number 2, and then you simply get your radio or whatever. Now you take the 1% admin expenses. The factor is the one that we know as usual, and then we have a payment of $172. Now your loan is this minus this. This is what you receive, and the 171 are the cash flows, and then you simply take the internal rate of return of this, and then you get 2.98. Of course, guys, which one do you select? And this is normally the case, guys. Well, you select the bank. However, guys, what happens with the banks is that they are heavier. It's harder to get a loan from the bank than getting to the store. If you go to the store, you simply go and pick up the product and they give you the loan immediately. Got it? Going to a bank is a kind of trickier. Okay, so now more and more, guys, what is happening? The stores have a bank office in their own stores. Have you seen that? I don't know how it's in South Africa, but here in USA, if you go to a retailer, you find a bank office, and this bank office offers you almost instantly loans for buying something in the store. Make sense to you guys? Guys?
Yes, but
Perfect. Okay, guys, do you have questions?
Are you gonna send this Excel?
Yes, I will.
Okay.
Okay, guys, so we stop here. Let's take 5 minutes before starting the quiz number 1, and then we start at 6:30. I think 35. Okay, so in 5 minutes, please take a break, and then we talk about the quiz, and then we start the quiz. Okay, guys.
So, Professor, you're going to give us some time for questions before we start?
No questions.
Oh, okay.
Oh, the questions were last week, last class.
Oh, I thought it was now.
No, now is the quiz.
Before the quiz, I thought we will have time for questions.
No, remember.
Yeah, we didn't have time.
We didn't have
time. We didn't have time on Tuesday. That's why I believe
guys,
that's why Marina's asking.
On Tuesday we solved a bunch of exercises and was asking you guys, you have questions, because what we did on Tuesday, remember The first 45 minutes of the class was everything related to the exam.
Okay.
Not to the exam, to the quiz. Okay?
Okay. Okay.
Okay, guys, see you in 5 minutes. So let me prepare everything.